Okay, so in this video we're going to continue our topic of finding solutions for equations. Now, in the previous video we went over uh, just finding all the solutions, right, across the domain of our function. All right, but now we're going to focus on just some finite domain. Now, usually students, I find, they find finding all the solutions is a bit challenging, right, or just kind of hard to do, right? But I actually find once you do that work of finding all solutions, then this part here just becomes a matter of plugging in values. So I prefer to just find all the solutions, and then if I have a finite interval, I can use those equations that I found to simply find the values that fall in that domain. So let me explain what I mean, right? So this example, right, we'll go over examples that we covered in the previous video because we've done all the hard work, right? So in the previous video we solved root 2 over 2, right? And we found that the solutions are of the form x equals 2 pi over 4 plus 2 pi k, x equals to 7 pi over 4 plus 2 pi k, where k is some integer. Okay. All right, now let's say that I was asked to find, so I have the solutions already, but let's say that we got to the end of it and the problem actually asked me to find all solutions in the interval 0 to 2 pi. Okay, all right, so all we have to do here is plug in values for k, right? Now keep in mind k is an integer, right? So what that means is, right, k takes on values like this, right? -2, -1, -2, -3, etc. in the negative direction, 0, 1, 2, 3, etc. in the positive direction, right? Integers. All right, now look at here, I can already not worry about negatives because 2 pi, when I plug in -1, for example, right, this is going to give me some negative value, right? This is much less than 2 pi. That's also less than 2 pi. So adding 1, 2 pi, that's just going to be too much. It'll put me in the negative values. So I know that right away. I don't need to worry about the negative values. Right now, when I plug in 0, so I'll start at 0, and I said, all right, let me look at k equals to 0. Right, that one's easy, right? When k is 0, this 2 pi just reduces to 0, right? 0 times any number, you just get right away 0. X equals 2 pi over 4, and x equals to 7 pi over 4. That's great, right? It is in my interval, right? It is between 0 and 2 pi. Okay, so let's move on and say, all right, what about when k is equal to 1? Okay, when k is 1, right, so we got 2 pi times 1, it's just 2 pi. So we got x is equal to pi over 4 plus 2 pi, x equal to 7 pi over 4 plus 2 pi. Okay, and then having a like denominator here, this will be 8 pi over 4, which is 9 pi over 4. Right, now, is this in my interval, right? 9 pi over 4 is just a bit bigger than 2 pi, right? 9/4 is 2 1/4, right? So that is outside of my interval. So that is not in my interval. And what you'd expect here is, well, 7 pi over 4 is bigger than pi over 4. This one should also be outside of my domain. So this is 15 pi over 4. We find that it is, right? This is closer to 4 pi. Okay. All right. So then right away we see, okay, well then, this here is also not part of my domain. Right? So I can stop here, right? When k is 2, I'll just get larger value, so also going to be outside of my domain. So in terms of my solution set, is the finite solution set of pi over 4 and 7 pi over 4. Okay, and these are the only solutions that satisfy this interval for our domain. Okay, so let's try another example here. All right, and we'll choose a different domain just to switch it up. All right, so let's see. So for this example, find all the solutions in the interval 0, let's say negative pi to 0. Okay. All right. Okay, so we're looking for values that fall between negative pi and 0. All right, like negative pi over 2, negative 3 pi over 4, etc. All right, and let's look at this problem, which we solved before, right? We solved in our previous finding all the solutions. Okay, so previously we found that x equals to 7 pi over 2. Excuse me, 7 pi over 12 plus pi k. And x equals to 11 pi over 12 plus pi k. Right, and here was k is an element of z. All right, k is some integer. Okay. All right, now looking at my interval, right, I'll start with k being 0. When k is equal to 0, right, we see this part here just becomes 0. So we got x is equal to 7 pi over 12. X is equal to 11 pi over 12. Right, but these are not in my interval. Right, these should either be 0 or a negative value between 0 and pi. Negative pi, excuse me. So I'm going to reject those solutions. Now, in the previous example, I started with 1, 2, etc. But here, if I do 1, I'll just get a larger positive value. So that's not going to be the direction that I'm going to go. So the next possible choice would be k is equal to negative 1. Okay, so let's start with this one. So we have 7 pi over 12. When I multiply by negative 1, we get negative pi, or we can think of it as minus pi, right? Or plus negative pi, however you want to think of these things. Okay, and for the other one, we get 11 pi over 12, and same deal here. Think of it as minus pi. Find a common denominator. In this case, right, since this is 1, common denominator would be 12. Minus 12 pi over 12, that gives me negative 5 pi over 12. And this is 11 pi over 12 minus . All right. And these very much fall in my interval, right? Remember, 12 pi over 12, negative 12 pi over 12 will be negative pi. So this is less than pi. Negative pi, excuse me. Between 0 and negative pi. Okay. So those check out. All right. Now we're not done, right? Let's see if negative 2 works. K equals negative 2. So again here, when I plug in negative 2, so negative 2 pi or minus 2 pi. Find the common denominator, which again would be 12. All right, so 24 minus 7, we would get 17, negative 17 pi over 12. Okay, and here 11 pi over 12 minus 24 pi over 12. And here we get, what do we get here? 13, negative 13 pi over 12. Okay. All right. All right, now looking at both of these, right, these values are just a bit, I guess, smaller or more on the negative pi, so they fall outside the interval, right? So these I can reject, right? And again, going up to -3 is something we don't need to do, right? Because then we'll get more negative values, right? Larger in the negative direction. So I can stop here and see, okay, I actually have just one pair of solutions here, right? So my solutions for this would be -5 pi over 12 and -pi over 12. Okay. All right. And that is how you would calculate solutions on a finite interval. Again, right, I always like to start finding all of them, right? Once I get comfortable with that, using this interval is simply a matter of just plugging values in and checking whether they fall on a certain interval. All right. One thing you want to watch out for, right, is, or just be mindful, right, as we go in the positive direction, right, once you've reached the limit, you don't need to keep going further, right? And the same in the negative direction. Okay. All right. Thank you.